Hi, my name is Karen and welcome back to Three Inquisitive Kids. In this video, we will be looking at the different properties of parallel lines. In this unit, a lot of the things we've learned so far are the different positional relationships between lines and angles. And in this lesson and the next one, we will be looking at parallel lines. So you'll find that a lot of the things we cover in this lesson have a lot to do with the previous two lessons in exploring the conditions of parallel lines. You may see some things being repeated or being looked at in a slightly different way. So if you haven't looked at the previous lessons yet, I totally recommend you to do so, and then you can come back where you'll understand what we're talking about even better. Anyways, here are the two learning goals of today. Grasp the properties of parallel lines. Use two straight lines to judge whether angles are equal or supplementary. Perform simple reasoning and calculations based on the properties of parallel lines. Introduction. Review and think. What are the ways you can determine parallel lines? Well, the three different ways we've looked at so far in this unit is when corresponding angles are congruent, alternate interior angles are congruent, and when same side interior angles are parallel. If any of these are true, then we know that the two lines are parallel. Conversely, if one of these are true, we know that the two others are true as well. So, conversely, if two lines are parallel, what is the relationship between corresponding angles, alternate interior angles, and same-side interior angles? We know that this box leads us immediately to this next box. If this, then that. This is the direction that these arrows are pointing in. But is it still true the other way? If we only knew that two lines were parallel, do we know for sure that these three properties are true? That's what we're going to look at today. Properties of parallel lines. Line C intersects parallel lines A and B, so we already know that lines A and B are parallel. Take any random angle formed by these three lines and find its measure. With that, you can figure out the measure of any other angle. What it's saying is if we take any angle and we measure it, using that one measurement, we can find out every other angle without measuring them, directly using a ruler. What is the relationship between the degrees of pairs of corresponding and interior angles? I want you to try this on a piece of paper. Just draw something approximate. You don't even have to really measure it out. Say give 1 30 degrees and fill out this table. What will every other angle be? And I know not every single angle is marked up here, but all you have to do is just mark it on your own piece of paper and then fill it out. Based off of your conclusion, I want you to answer this question. What is the relationship between the degrees of pairs of corresponding and interior angles? Pause the video and try that by yourself. When parallel lines are intersected by a third line, corresponding angles are blank, alternate interior angles are blank, and same-side interior angles are blank. So using your experiment, you'll see that corresponding angles are congruent, alternate interior angles are congruent, and same-side interior angles are supplementary. So far it seems it is true the other way around. When parallel lines are intersected by a third line, these three properties still hold true. Now you kind of understand what I meant when at the beginning of the lesson I said some of these things that we're going to cover in this lesson we have already actually looked at in the previous lessons. Really, we knew that corresponding angles, alternate interior angles, and same-side interior angles, when they meet a certain criterion, we know that the two lines are immediately parallel. So this is really just looking at it the other way. Draw any random transversal D, then find the measure of each angle the same way. Is your prediction still valid? What we're essentially doing is just changing the measure of that first angle that you gave a measurement to. So say for angle 1, if at first you gave it 30 degrees, now try 45 degrees, 90 degrees, 65 degrees. Try different degrees like that and see if this prediction right here is still true. Again, pause the video and test it out by yourself. If you performed everything correctly, you'll see that, in fact, it does still hold true. This angle right here and this angle right here, they're corresponding angles. And when we overlap them, we see that they are about the same measurement. But if the two straight lines are not parallel, is the above conclusion still valid? So now draw something like this. Is your prediction still true? Well, if we take the corresponding angles from this figure, it's very obvious that they are not the same angle measurement, which means that if two straight lines are not parallel, the conclusion is not true. So from this, we know properties of parallel lines. Property 1. When two parallel lines are intersected by a third line, corresponding angles are congruent. Mathematically, A is parallel to B, then angle 1 is equal to angle 2. Corresponding angles are congruent when lines are parallel. And the main difference here is that you have to understand, we didn't say when two lines are intercepted by a third line and the corresponding angles are congruent, then these two lines are parallel. That's what we looked at in the previous two videos. But in this video, we're instead saying, if we already know that the two lines are parallel, then corresponding angles are congruent. The order switch, the cause and the effect switch around. But this is very important because not every theorem is like this. For example, triangles with each of their three interior angles at the measure of 60 degrees is a type of isosceles triangle. So here we're saying if it is an equilateral triangle, then it is also an isosceles triangle. But an isosceles triangle is not always an equilateral triangle. So do you see how whenever you flip the cause and effect around, it's not always true? As shown, given A is parallel to B, then are angles 2 and 3 congruent? Why or why not? Here's a solution. Because A is parallel to B, that's given, then we know that angle 1 is equal to angle 2, because corresponding angles are congruent when lines are parallel. Also, because angle 1 is equal to angle 3, since we know that vertical angles are congruent, we know that angle 2 is equal to angle 3, using substitution. Here's another conclusion we have. Property 2. When two parallel lines are intersected by a third line, alternate interior angles are congruent. Mathematically, if A is parallel to B, that's given, then angle 2 is equal to angle 3, because we know that alternate interior angles are congruent when lines are parallel. Again, back to that triangle example. I just want to show you how we might sort this. So say you were being asked to sort the category of isosceles triangles and equilateral triangles. It might look something like this. If this big circle is isosceles triangles, this smaller circle would be equilateral. Because equilateral triangles are a type of isosceles triangles. When A, then B, so if we have a sentence that's if A, then B, it's not always true when we flip it around and we say if B, then A. As shown, if A is parallel to B, then what relationship do angles 2 and 4 have? Why or why not? So here you want to explain the relationship between angles 2 and 4. Well, because A is parallel to B, then we know that angle 1 is equal to angle 2. Also, because angle 1 plus angle 4 is equal to 180 degrees, the definition of supplementary angles, Then angle 2 plus angle 4 is equal to 180 degrees. Substitution. Here angles 1 and 4 add up to 180 degrees because they form a linear pair. Our final conclusion is when two parallel lines are intersected by a third line, same side interior angles are supplementary. Again, we covered this kind of in the past lesson, except this is the other way around. So whenever you're explaining or reasoning in your solutions, be careful of the way you explain things, because sometimes that could mean a few extra points or a few less. Mathematically, if A is parallel to B, then angle 2 plus angle 4 is equal to 180 degrees. Discuss. What are the conditions for the three properties of parallel lines, and what is the conclusion? Two angles are parallel. If this is true, then all three of these properties are true. But also, if all three of these properties are true, then we know that the two lines are parallel. Let's do a problem. Example 1. As shown, there is a trapezoidal piece of iron. Angle A is equal to 100 degrees, and angle B is equal to 115 degrees. What is the measure of angles C and D? Now I want you to use the properties of parallel lines that we just learned to solve this problem. Pause the video and try it by yourself first. Here's the solution. Because we know it's a trapezoid, then the upper and lower sides of the figure are parallel. CD is parallel to AB. So angle D and angle A are supplementary, and angle B and angle C are supplementary. Therefore, angle D is equal to 180 degrees, taking away angle A, which is 80 degrees. And angle C is 180 degrees, subtract angle B, which is 65 degrees. Therefore, angle D is equal to 80 degrees and angle C is equal to 65 degrees. Alright, let's do another problem. Given that angle 3 has a measure of 45 degrees, and that angles 1 and 2 are complementary, prove if AB is parallel to CD. Again, pause the video and use the properties of parallel lines to help you solve. So here is the solution. Since angles 1 and 2 are vertical angles, we know that they are equal to each other. Also, because angle 1 plus angle 2 is equal to 90 degrees, which is given, so we know that angle 1 is equal to angle 2, which is 45 degrees. Because angle 3 is equal to 45 degrees, given, we know that angle 2 is equal to angle 3. Therefore, AB is parallel to CD. Because since we know angles 2 and 3 are congruent and that they are alternate interior angles, AB is parallel to CD. Lesson summary. Today we grasped the properties of parallel lines and used two straight lines to judge whether angles are equal or supplementary. We were also able to perform simple reasoning and calculations based on the properties of parallel lines. Parallel lines and just the process of proving something using theorems are something that is a very important skill to have, especially as you move up in your math career. So this is a very important skill to have, and if you didn't understand something, you can always go back or you can ask in the comments down below. We are very happy to answer your questions. So thank you for watching through Inquisitive Kids, and we'll see you next time.